Test, test. There we go. There we go. Can somebody talk?
Hello.
So we should be hearing that now. All right. Let's see here. Lower this down a little bit. Cool, cool, cool. Well, welcome. So the topic is recursion, and I don't think it's something that web programmers are super privy to. It's something that's taught in school often, but it's not used a lot. And there's some good examples in web development where recursion is extremely useful. And that's what we're going to cover. So I'm going to cover just pretty much the basics of recursion at two levels, like one from the level of just dealing with an integer, and then as well as dealing with actually like a complex object, an array of objects. Shutting Windows. So is anyone here familiar with the idea of recursion? Up in chat.
I am a little, maybe.
Cool. Well, I'm gonna start super basic that way, like the computer scientists or the programmers in the room. I want it like so. Chloe, I mean, you obviously play with code, so, but maybe not at this level. So, I'm just gonna start. What I'm doing is I'm running a node, so I have an index.js, and how I'm gonna test this is by console logging. So, I'm gonna say, I'll use var. So var a equals 1. Right, so this is kind of like, I guess would be algebra, right? Basic arithmetic. Alright, so I'm going to save that, and then in my terminal here, how I'm going to test the output is, since I'm running node, I can just say node index.js. And then in my terminal, the output is 1. I don't know, is that too small? Can you, I don't know if you guys can see that. See if I can kick it up here. There we
I can
go.
see it.
Nice and big.
Yeah.
No excuses now. You can definitely see it. So the output is 1, right? So now if I was to say, var b equals 2, and then I was to say var c equals a plus 1, or a plus b, excuse me. Alright, and now we're going to output c. Alright, so what do we expect? 3, right? So that's like the basic, right? This is the basis. And now if I was to say, I'm just going to create a function, and we'll give it a name. So I'm just going to say function add takes an a and b, and it returns, I guess in our case, we're going to console log, because we're going to console log a plus b. And we're going to call this function here non returns nothing. Let's see. Not sure if I can do that in a console log, so we're just going to say
Are you passing A and B?
Oh, you're right. That's probably why it's upset. Thank you, Giselle. So then I'm going to pass A and B. See, that's why I have you guys here. So, and then run this over here, and the answer is 3. So this is like the basic concept of a function, all right? And this is kind of what jumps you off, like there's like, cosine tangents. I think this is like the jump to precalculus, like in basic math. But your basic like algebra is going to be like casting something to AB. What's AB? I kind of remember that from 50 years ago when I was in school.
Getting there.
Yeah, it's pretty close.
Really?
I think that would have been, geez, man, maybe 30, 25 years ago. It's pretty close. So this is the concept. So add runs, and the output is 3. So also in computer science, there's this concept of for loops. So you can say for something. So I'm going to continue. Um, I'm I'll just keep calling it add. So you can say something like for you declare a variable. I'm just going to use var here because not to confuse people with the different declarations in JavaScript. So I can say var I equals 0. And in a for loop, you declare the variable just like I declared a up there. I'm saying I. I is what's used common here for index. So I could say, and the second part is like a while statement. So this will run. So while I is less than 0. And then every iteration of a for loop, it will kick I up a notch, right? And then this number, I'm going to change to be, just say like limit or something like that. So limit is going to be how far I want to go. And I'm gonna delete these now, just so I don't need them anymore. So my limit is the integer I'm going to pass into this. I'm just going to call this run for now. Get rid of add. So I now have a function named run. It's going to take an integer called limit, and I'm just going to call this 40. We'll call it 38. And so what this is going to do, it's going to declare a 0. It's going to say while I is less than the limit, which the limit right now is 38, every time it runs through this once, it's going to kick I up once. Right? So this is going to run until it is 38. And what I'm going to do is I'm just going to output I here. So now over here, when I run the program, it's going to kick it all the way out. And why we get the 37 is because we start at 0. So we have 38 outputs, but we get to 37. If I was to say, while I is greater than or equal to the limit, rerun this, I'll get to 38. So this is iteration. So this is using a statement, and computer science is so common. It's practically in every single language except for some languages, like Scheme, for example. Scheme is a language that purposely doesn't require iteration statements like for or while. So this is standard computer science. Now we're going to talk about recursion. So recursion is the idea that you can run something without running. I mean, pretty much you don't have to for loop. This program's going to run until it decides not to run anymore, without using a for loop. Some examples of recursion can use for loops, and we'll end up using one eventually to show you. But in this situation, I'm going to restart my function. So run is the name of my function. It could be named anything, but we're just going to call it run. And I'm going to have it start. So in my function, we'll just start simply by outputting start. We're going to start at 1. So I'm going to run my function again. Clear this out. And my output is 1. So I can do something clever. I could say if start is, let's just say, less than 38, I'm going to call it again. And I'm going to call this function with start plus 1. So what's happening here is it's calling itself. That's like the recursive nature of it, is that run's going to run. It's going to check this clause, and it's going to say if the number start, which is starting at 1, is less than number 38, run it again. And this time I'm, making it tricky. I'm saying start plus 1. All right, so what do we expect the output of this to be? Let me save and run. it runs all the way until it hits 38 and exits the program. So this is the most basic concept of recursion. Um, and it's the idea that the program just calls itself. So if you notice, I'm not running a iteration of for loop. It's actually just calling itself and rerunning. Any questions or comments about where I'm going here? Can be anything. All right, silence. So I think you're all following me. Chloe, go for it. Let's hear what you got.
No, I was just gonna say it's making sense so far.
Okay, cool.
I'm following you. This reminds me of programming in college.
Yeah. So the back in the day, before like for loops iteration, like all you really had was recursion. And when I was going to school, they trained me on a language called Scheme, and Scheme had no loops, had no for loops or while statements or any like iterative statement in it. So it was really confusing because everything was recursion, and at the time, like you don't really grasp it. So I had to write full programs only written with recursion, only functions calling themselves. It's pretty wild. It was really good foundational. I hated learning it because it wasn't building video games, and they were teaching me stuff I felt like didn't apply, but it does apply. It even applies when building interfaces. Where it would apply is like if you're building a navigation or a tree, something like that. So this is the basic steps. Now this is just dealing with an integer. Now with the programs we use today, we have the ability to have access to objects and arrays. An array is a set of different types, so it could be a set of numbers. So I'm going to create an array to show you all what an array is. So I'll say var, I'll just call it my array equals, and it literally like the brackets practically look. Just imagine this is a bucket, and each one of these 1, 2, 3. So there's 3 entries in this array, and you can see them here. And I'm pretty sure if I was to console log this array, I wonder how it outputs if the output shows you it in an interesting visual way. Clear that. Yeah, so see it kind of outputs it almost as is, but I always look at this array as like buckets, right? So in this particular array, there's integers. And in object-oriented languages, you can have something called objects. So say I was to make an object. Objects in JavaScript and in many languages are encapsulated like this. They use curly brackets. And you could have something like name, say Randy. And it's not always the case, but it's nice that when you have an array, it should be all of the same type. It doesn't have to be, you can break the rules, but we're just going to use the same type. So we're going to now have 3 objects. We're going to go right from the top. I think we have SGN up there, and then Bobby as the top 3 people I see in Discord right now. So Randy, Jen, Bobby. So now I have an array with 3 objects in it. And you can see the output just starts, it's like, again, it's like imagine this bucket, and then each one of these little slots, is an object. So arrays can be, or an object can hold more things than just, this is a string. It can hold integers, it can hold another object, it can hold an array. So for the sake of this example, I'm going to create an array with children. Randy has children. And each children is going to be an object like the top array. So this one is going to need a comma there. So children also have a name. Let's just call it, I have a child named Eliza. I don't know if Gian and Bobby have children. We're gonna make up figurative children for you guys right now. Don't be scared. And then say Eliza has no children, so she'll have an empty array in this scenario. I have another one. Isaac, and let's pretend Isaac has children named after himself and his siblings. So what I'm doing is I'm building like a very complex array of objects is what I'm doing. So it's hard. This is hard to follow visually. Like it becomes quite messy. But it's kind of the trick is like when something's complicated like this, humans like stop to not being able to read it. It's not being able to follow it. It becomes very hard to follow. And that's where computers are great, right? That's it. Do the things that humans don't have the capacity to do. I'm building out an array of objects. Is everybody still following? It's okay if it's like becoming abstract, but any questions here?
Yep, no, I am.
Okay. And it gets to look complicated, but pretty much the key thing is that the structure, I'm trying to keep us the same structure. So every object has a name and children, right? And the children of the same thing. They're going to have a name and children, right? Same concept. So Gian and Bobby, we're going to give Gian no children, and Bobby, you're going to coincidentally have a lot of children. More children than me. You're going to have my family times 10. So I can take this whole entire array, and this is where it's going to look really messy. Bobby's going to literally have all of this under her like that. So now we have this extremely complicated, I guess we need empty like this.
Can you close your sidebar? You get more real estate?
Yeah, good call. Thank you. So now we have a complicated array of objects, right? And there's Randy and Randy's children and his children's children. Jian's got no children yet. That'll probably change during the course of this demonstration. And Bobby's got literally her children equal what the current array of children are. And just to make sure that this thing is good, I'm going to just console log the array to make sure that the program doesn't break. And yeah, the console won't even, there's so many things to display, the console log's like, no, not going to do it. It'll just represent all that as objects. Okay, so the goal is to run through this. And we can use recursion to run through this and build an output, like say like a family tree or something like that. But really it could be like a file system if you think like files and directories and all these directories and whatnot. So we're gonna, since we're using the concepts of human names and children, we'll just say we're gonna output a family tree. So how do we do that with recursion? I'm going to change start. So we're going to keep the program named run, right? And we're going to continue doing our console log to get information. So we're going to take my array here, and I'm going to collapse this down. I'm just hiding it for cleanliness. And we're going to pass in my array. And we're just going to start this. I'm going to comment this out. We're just going to start to see, can we run this program and just have it output the array on the right? Just to walk our way, and it does. It outputs the array. So before we had an if statement, and I'm going to keep that up just to show you all. So we said if start is less than 38. So we know in array we have information we can work with. So we could say something like if array dot children, and then how you can check the length of an array in JavaScript is just literally typing length. So we could say if the array length, if it has children, is greater than 0, run itself with children.
Randy, you might run into an issue. You've got a couple extra commas in your object.
Oh, I do? I don't know. Will that be an issue?
Dun, dun, dun.
Yeah, like line 19, for example, does not need a comma.
Yeah, it could, when you're not doing a structured JSON, if you're just doing an object in JavaScript, you can be a little bit looser, which is nice. Okay, so we'll see if I run into that. So I'm going to run array. I'm going to console log out the array, and I'm going to say if the array, I guess it's going to be an object. So I'm going to start. I'm not going to start this off as an array. Let's see. I remember I ran into this before when I was training. So it starts with an array. I think it starts with the object. I'm gonna cheat and look at the other reference, but
You could just target the first index, right? So index 0, and then go check the children length of index 0 of each array.
yeah. I guess if I run a for each on it with the children.
Or ideally, you would have a root node,
Yeah,
so like one
I think
great grandfather.
Yeah, the root node is the one that I want. So I would imagine that then the root node would be like this. Yeah. So it'd say name. I'm just gonna call it root, and then the children of that root would be the whole. Yeah, like this. I believe that would then be like this, and then I would just need one more closing bracket. Thanks. Alright, so we now have a root. And that root has children to get us started with. So that way then everything's the same. So the top level is a single object. Alright, so we're going to output this. And so really this is going to be object, not an array, because the children is the array. So what we're going to do to start is we're going to output the name. And we're going to say if children's length is greater than this, we will then rerun the program. So the program takes an object and children is an array. So this is where we could say, this is where we're going to need to use iteration, unless I was to build another function, but I'm not going to. So then I would, here I'm going to say object dot children. I believe I can just use a for each here, and this would be child run child run. I believe that should work. So if it's right, it's just going to output everybody's name. And there we go. So what this function did with whatever, what is that, four lines of code, it ran through this whole entire object and got every single child and named it out. I'm going to stop here to say any questions. It's kind of magical. But basically what it's doing is it goes to the object, it outputs the name, so it's always going to output the name. And then it's going to see if that object has children by checking the length of like how many items are inside the child array. It's over 0. And then what this does, it says if for each child run, like recurse, like run against itself. So that's recursing over recursion. That's recursing. Excuse me. That's recursing over a very complex, right? It's a complex setup here. It's a complex array of objects. So now if we wanted to treat it differently, so say like this is just outputting a name. So say I wanted to make it look like a tree. What I'm going to do is I'm going to pass in, we're going to call it spaces equals 1. And then above this, I'm going to make a, I think it'd be a for each loop. So I just say for I equals 0. So I'm going to use that for loop again. So what I want to do is I want to create a length of spaces. So I'm going to say let the spaces equals an empty string. Say for. And I'll say while I is less than spaces, I'll say less than equals here. I plus plus. And then we'll say space plus equals. So it's funny because this is like as much code as the whole thing. So 4 more lines of code. And what we're going to do is for every iteration we have based upon what level of the root we are, we're going to add spaces. And we'll see what that output looks like. So in my console log, this is what we're getting over here is this console log. I'm just going to put spaces in front of the name like this. And then when I run, I'm going to add the spaces just like I did in our original. I'll just say spaces plus 1. So if you remember in our original integer example, right, we did this, something similar. So let's now run through and see what happens. That's giving me the number. I actually want the word space. You can see as it's doing its thing though. You'll see it's easy to see more visually. So now it knows, like, here's Randy, here's his 2 children, here's Isaac's children. So now you can see that we're starting to create a tree, and it may be even more apparent if I use just /t is for tab. So I can actually use like tabs to kick them out more. Ooh, that's too much. Let's go like that. Maybe we'll just use a couple spaces instead of a tab. 1, 2.
Could you try dashes and see how that looks?
Yeah, we could try that too. That's a little bit easier to read there. Let's go 1 more space. Let's see if this will do it. Yeah, I feel like that's easy to read. All right, I'm gonna stop here. Any questions around this?
Is there an advantage to using an if statement on like line 77 as opposed to a while loop?
I guess you could. Yeah, you could just while through the children. You're right. You could definitely do that, and then cut these down. So where the if would come into play, if children had types, like if they were like if they had a type like, I don't know, or maybe like a location like Massachusetts versus Rhode Island or California versus Rhode Island, an if statement would be of value at some point, I guess within the while loop. But then you can decide to do different things, because if you had a different recursive function for people who lived in different parts of the country, you can get certain types of output. So in that situation, for this, a while statement would work. But if you're going to be expanding it out, you definitely would have some sort of like switch or clause statement. So coming back to this, now if I want to build, so this starts to look like a tree. If I want to build a ULLI setup, right? I would want to start like this. So we're going to do li. So li in HTML is list item. So, and then I'm going to run this again. And I'm actually going to put the space on the outside so it's more visual. Right, so I'm getting LIs. Now, if I want to properly wrap these inside of a ULLI, and this is where having the if statement comes into play, by the way, Bobby. So you'll see, so I can console log now dot log, and then I'll say space plus ul. And since my iteration of children happens below the fold, I'll say slash. So now I can output. And now you can see I have proper HTML tree right here. And that's where the if statement like shows its value. Versus just running a while loop. So pretty cool. So that's how you'd build a perfect tree using recursion. And this array of, I can now take, say, this whole entire children object again, and just to make it even crazier, let's give this Isaac person who's pretty deep all these children again, and just rerun this program, and you'll see now I have it like more complicated. And the program just perfectly and elegantly handles all of it. So now you could have this endless tree no matter how many deep, whether it be like directories or children or family tree that's 1,000 generations. Like it just all runs and against a single, very simple function that talks to itself, that calls itself. So that concludes my recursion lesson. Happy to answer any questions or comments or also feedback too if you, I don't know, if you enjoyed this or if this is news to you or whatnot, but opening the floor.
This brings back a lot of memories.
That's good, Todd. We gotta
Yeah, I know.
drive the cobwebs up there.
Remember, but I was doing this on, VAX mainframes.
Yeah. Recursion could be very dangerous too, because it could run.
Yeah.
You could, if you don't have a stop to it, it'll run forever. So you can
Yep.
you can crash computers with recursion. It can be used negatively, used for good, right? We'll use it for good. But it's super awesome, and Parsley obviously exists because of recursion. Every computer language tokenizes and runs recursion to read through it. So yeah, it's good stuff. It's a good foundation. It's definitely not used a lot in the front end, right? So yeah, I feel like the only time I run into it for front end would be like building tree navigations that are deep, or I mean, we're building the drag and drop tool, for example. It is only possible with recursion. So there you have it. That concludes Learn Something Friday. You're all a little bit smarter, I hope, or maybe stupider. We'll see.
No, this is awesome. Thanks.
Yeah, for sure.
Cool. All right, everybody. Take care and have a happy Friday.
See ya.
See ya.
Bye, guys.
Bye.